In this video, we're going to look at how you take one log expression and expand it into a sum or a difference of logs. And that's how it's explained sometimes, or how it's written. It'll say write the expression as a sum and or a difference of logs. In order to do this, you have to do it in a certain order. First of all, you want to take your expression or your argument, and you're going to split it first using the product or the quotient rule. And then after you've done that, you're going to move your exponents down using the power rule. The only exception to doing it in this order is if your entire expression is in parentheses or something and it's raised to a power. So we'll look at that as it comes. Okay, so for your first example, we have log base 3 of 7x. So you want to look at your argument. Your argument is 7x, and you want to decide if that's a product or a quotient. Obviously, that's a product. And so if we look at our log properties, we see that products become written as addition. So we're going to split our expression right here. We're going to split the 7 and the x into an addition problem. When you split it up, that base 3 has to go with each log. So it's going to be log base 3 of 7 plus log base 3 of x. After you've done that, the next thing you want to do is you want to look at each of your individual arguments and see if there's any exponents that need to be pulled down to the front, like this, using the power rule. But in this case, we don't have any exponents, so that's our final answer. That is our log written in expanded form. All right, for our second example, we have log base 5 of 6w to the fourth. So our argument, 6w to the fourth, is a product again because we have 6 times w to the fourth. So we're going to split that right here into addition again since it's a product. We're not going to worry about that 4 yet because it's a power. All right, so we're going to have log base 5 of 6 plus log base 5 of w to the fourth. Okay, so we've done the product rule. Then you look for your powers and see if there are any powers you need to bring to the front. The 6 doesn't have a power, but the w does. It has a power of a 4. So you're going to take that 4 and bring it to the front to make it multiplication. All right, so when we rewrite our answer, it would be log base 5 of 6 plus 4 times log base 5 of w. That's your final answer. Third example, we have log with no base, so that's a common base of 10. Log of 2c over 9. So in this particular problem, our argument is 2c over 9. We have a product and we have a quotient since we're dividing by 9. So when we split this up, we're going to split it into 3 parts. We have 2 times c, so we're going to split that up into addition. But then we're dividing by 9, so that's going to be the quotient rule, and it's going to split into subtraction. So 3 parts here. And since it's a base 10, that's understood. We don't have to write it. So it would be log of 2 plus log of c minus log of 9. If you wanted to, if it's hard to do all that in one step, you could do it in 2 steps. You could do log of 2 plus log of c in one step, split that, and then add on the minus log of 9 at the end if you wanted to in a separate step. Okay, next example, same type scenario, but the product's on the bottom. All right, so we have a quotient here. We're dividing by y cubed and we're dividing by z to the fourth. There's a couple ways to think of this, and so to avoid some confusion, I'm going to do it in 2 steps here. Some people may look at this and think of it as I'm dividing by y and I'm dividing by z. So you think of it as dividing by 2 things, so they're both going to be subtraction. Or others may look at it and think of it as this right here on the bottom is a product because they're being multiplied together. So you may think of that as needing to be separated as addition. And both of those are correct. So I'm going to show you how it comes out. If you split it up in 2 steps, we have log 8 of x squared minus, I'm going to do it as a quotient first, log base 8 of y cubed z to the 4th. I'm keeping all that together because we're dividing by that entire thing. So right now I'm keeping it all together as a quotient. Okay, so subtraction because we're dividing by all that. So that's my first step. But now I can look at it again and say, okay, I did separate it as a quotient because I was dividing by all that, but I still have a product here that needs to be split again. I'm not completely done if I still have a product here. So now I need to go one step further and split that. Okay, when I go to split that, because there's a minus sign on this entire thing, that minus is going to get distributed eventually. So here's what happens next. We have log base 8 of x squared minus log base 8 of y cubed plus, because this is a product, log base 8 of z to the 4th. Okay, when you see it like that, you see that that negative now is going to go to both parts. And so it ends up becoming log base 8 of x squared minus log base 8 of y cubed minus log base 8 of z to the 4th. So I do all that just to say that basically when you look at your problem, anything that's in a denominator is going to come out to be subtraction in the end. So I wanted to show you how it comes out that way, because I know some people are going to look at this and see that that's a product in the bottom. And because it's a product, you're going to think addition. And it is addition to begin with. But because that whole thing was being divided, that negative that was on the entire thing actually ends up getting distributed to that addition and makes them both negative anyway. So you can skip all these steps that I just showed you. I want to show you why it works. But just know when you look at a problem, anything in the denominator ends up becoming negative anyway because it is being divided. Okay, so the two things in the bottom came out negative. And now we're not finished because we have all these powers that need to come down to the front of our logs. Okay, so the 2 comes down to the front of this one, and we have 2 log base 8 of x. 3 comes down to the front of this one, 3 log base 8 of y, and 4 to the front of this one, 4 log base 8 of z, and that's your final answer. Okay. Now, for this next example, it's the first time we've seen a square root in a problem. One thing that you kind of need to remember for this is when you have a variable or anything raised or anything to a square root, like the square root of x is the same thing as x to the 1/2 power. You need to know that for these log problems. So another way to write this log right here is natural log of 3 times a to the 1/2 power. When you're dealing with these expanding and condensing problems, those square roots and cube roots need to be rewritten as exponents so that you can move your exponents where they need to be. Same thing with a cube root. The cube root of x is the same thing as x to the 1/3 power. So keep that in mind whenever you're doing these problems. Okay, so this problem, now that it's written like that, is very similar to this problem right here. We're going to split it right here first. It's a product. Okay, so it's going to become natural log of 3 plus natural log of a to the 1/2 power using the product rule. And then you look at your powers. We do have a 1/2 power that needs to pull down. So final answer would be natural log 3 plus 1/2 natural log a. That would be your final answer for that one. One thing I want to mention too is in any of these problems, if there already happens to be a number in front of your log, and then you have to bring a power down also, that power would get multiplied by whatever number's out here. So in your problem, if there happens to already be a number in front of your log, and then you're bringing a number down in front of your log as well, you would just multiply those numbers together. Okay, and then we have one more expanding problem, and this is an example of a problem where the entire argument is being raised to a power. So this is one of those problems where you can kind of reverse the order that you work through the expanding because of the entire thing being raised to a power. The whole thing is in a cube root, so that's like saying the entire thing is to the 1/3 power. So in order to do this problem correctly, instead of splitting it up first, you actually want to do the power first to get rid of those parentheses. And so this is the only time you reverse that order. Bring the 1/3 down. And so you'll have 1/3 log of 4 over AB. And then once you get that 1/3 off, now you can split your argument up. And so this is another one of those scenarios where you have two things on the bottom. So it does look like a product down here, but think of it as, instead of a product of A and B, think of it as I'm dividing by A, but I'm also dividing by B. So both of these are going to be subtractions. Okay, so when you split this argument up and you subtract both of these, so you're going to have three logs, a log for the 4, a log for the A, and a log for the B. That 1/3 that's out front has to go on every single log since it's in front of the entire thing. So it'll be 1/3 log 4, and then the A is on the bottom, so it's subtraction, minus 1/3 log A. Same thing for B, minus 1/3 log B. And that would be your final answer. So the only time that you want to do your powers first is on a problem like this where the entire thing is raised to a power and you want to get rid of it so that you can work with what's on the inside.